This is 7.4, part 2. We're going to do a few more examples with the trig ratios. In the last video, we had seen the trig ratios for angle A. I'm just going to redo the example, but for angle C this time. So we're just going to do it for angle C. The ratio always pertains to a certain angle. So I'm just going to erase what I did for angle A here. You can go back and compare for angle A in the previous video. And then we're going to take a look at how we would have filled out these trig ratios for angle C. So always start off by labeling your triangle for the angle in particular. So here we have angle C that we're dealing with this time. So angle C is over here. And we want to label our hypotenuse. Our hypotenuse is always the one that's opposite to the 90-degree angle, so that's not going to change here. So this is our hypotenuse over here. And then for our opposite side of angle C, that would be the 12 this time. In angle A, that was the adjacent side, meaning next to. For our adjacent side for angle C, it's going to be this one over here. It's next to angle C, so adjacent side. So we have our adjacent, opposite, hypotenuse. And so if we want to find the sine of angle C, we know that would be sine is so, opposite over hypotenuse, so op over hypotenuse, which would be 12, that's the opposite side of angle C, over 13. If we want to do cos of angle C, cos is ka, AH, adjacent over hypotenuse, so adjacent over hypotenuse. Adjacent is 5, hypotenuse is 13, so 5 over 13. And lastly, if we want to do tan of angle C, we would do tan is toa, so opposite over adjacent, which would be 12 is the opposite, adjacent is 5, so 12 over 5. And so that would be our trig ratios for angle C. Let's go and practice with our calculator now. We're going to practice using our calculator to evaluate different sine, cosine, and tans of different angles. So if I give you an angle and I ask you to find the sine of that angle, you would write it like this. You'd write sine and then the angle next to it, or cos, if you were doing a cosine, cos and the angle next to it, or tan and the angle next to it. So in this case, sine of 82 is equal to, and we want to 4 decimal places in this question. So when you go to your calculator, you need to make sure it's in the correct mode. If you've watched a tutorial, you know what I mean. If you didn't, go back and watch the tutorial. You want to make sure your mode is in degrees, because later on you'll learn there's different ways to represent angles. If you click on your mode button on your calculator, you'll see degrees, you'll see rad, you'll see grad. Those are different systems for angles. We're using degrees, which is what you're more familiar with. So want to make sure you're in that mode. If you're not in that mode, you're going to get the wrong answer. So what you do next is, once you're in the degree mode, you'll see DEG or D. It might vary depending on your calculator. You can just Google your calculator if it's not in the video that I posted, and you'll figure it out. You just need to actually do it. So when you're doing your assessments, make sure you bring your calculator that you're familiar with, right? So you can't rely on borrowing someone's calculator. You need to know yours, because every calculator is different. So what you do next is you press the sine button on your calculator, and then input the degrees, so 82 degrees, sine of 82, right next to it, and I get 0.99026, so around a 03. 9903. And that's the 4 decimal places. Same idea for cos, for the cos. So you do cos 11 is equal to, so cos of angle 11, so I'm going to go on my calculator, it's deg, in degrees mode. I'm going to push cos, put the number 11 next to it, and then push equals, and I get 0.9816. And then it's the same idea for tan. I do tan 37 equals, so make sure it's in deg mode first, degrees mode. I push tan, and then I put 37, and I get 0.7536. 0.7536. So you should be trying this out and getting the same answers as me. If you are, that means you are doing the right steps. You're putting it in degrees mode, and you're pushing the right buttons at the right time. Now, let's see how we can go backwards. If I give you the cos of an angle, can you figure out what that angle was or is? And the answer is yes, you can. So to find the angle, you need to use the inverse function of sine, cos, and tan. The inverse looks like this. So if I was doing the inverse of cos, inverse means opposite, it would be the cos, and on your calculator you'll see a little -1 exponent. And in brackets I would put 0.4226 is equal to angle A. So the idea is this is cos of angle A. To uncos it, to do the opposite, you do the inverse cos. And so on your calculator, usually that's a second function. So you should know how to operate your second function on your calculator. What you would do is you would push second function. Still make sure your calculator is in degrees all the time. Find the button that has cos -1 on top. And then you can put in your cos value. So 0.4226. And I get how many decimal places? To the nearest degree. So we're rounding to the nearest degree in this case. In this case, I get 65 degrees. So angle A is equal to 65 degrees. It's the same thing for the other functions. So we know that your angle A is going to be equal to the inverse sine of 0.2419, which is going to be equal to, so again, we make sure it's in degrees mode, second function, find the sine -1 there, and then put in your 0.2419, and we get 13.99 degrees, so that's about 14 degrees to the nearest degree. And then same idea for the tan. If you have tan of an angle, to find what that angle is, what you want to do is the inverse tan. So we have tan, or I should say angle A is equal to inverse tan of 2.7475. So angle A is going to be, so again, make sure it's in degrees mode, so second function, inverse tan. You might not have second function, you might have shift on yours instead, depending on your calculator. Again, watch that tutorial, or look up your calculator on Google, or look at the instruction manual. So inverse tan of 2.7475 is 70.00015, so we want to round to the nearest degree, so 70 degrees. And so that's how you would solve for the angle if you were given the tan of that angle, or the sine of that angle, or the cos of that angle. And so notice we learned our baby steps. We learned how to find the sine of an angle. We learned how to do the inverse function to find the angle. So inverse gives you the angle. The sine, the cos, and the tan, not the inverse, but the actual functions, they gave you the ratio. So for example, the ratio we found up here with the sides, with the side lengths, that was given to us using the sine function, or the cos function, or the tan function. So these ratios are equivalent to the functions on your calculator. That's why we can eventually use these concepts together to solve a triangle, to find the missing sides, missing angles, and all that together. And so once we put all these pieces together, it'll make a lot more sense. Right now we're just really learning the primary functions. So let's solve for x. Let's see how we could solve for x. So if I give you a situation like this where you have sine 35 is equal to x over 8. How could you find what the value of x is? Well, you're just going to do your inverse operations to find what your x is. You're going to isolate for x, in other words. So we'd like to multiply both sides by 8 because 8's in the denominator, so we multiply this side by 8 and this side by 8 as well. That will cross 8 out over here, and so we get 8 times sine 35 is equal to x. Now, when you put this in your calculator, you need to be careful. First, there's a few ways you can do it. What I would do is I would push 8 and then do times sine 35. That way you're not going to put the 8 into the sine function. You make sure it comes before it. And I get 4.5886. I'm just going to round to 2 decimal places, so 4.59 is equal to x. So this would be kind of like finding a side, for example. Another way you could have done this is you could have done sine of 35 and then push equals and then do multiply by 8. But you have to push equals first. Otherwise, you might have accidentally put sine of 358, for example. So make sure you're doing it in the proper order, and make sure, again, you're in deg mode, degree mode. For every problem that we do here on end, you need to make sure you're in degrees all the time. So check that first. That's your number one, that's your first step every single time. Make sure you're in degrees. So let's say we want to solve for x in this situation here. So we want to isolate for x. Basically, we want to send x to the other side. So we're going to multiply by x. Multiply by x over here. So we get x tan 48. This x crosses out here. So we get x tan 48 is equal to 12.4, right? In other words, we just sent x to the other side. It becomes a multiplication. We still want to get x alone, so we're sending tan 48 to the other side. This whole thing goes to the other side. You can't just send the tan by itself. This is one number here, tan of 48. You send it to the other side. In other words, it becomes a division. So you're dividing both sides by tan 48. Over tan 48. Cross tan 48 out here, cross tan 48 out here. And so you get x is equal to 12.4 over tan 48, which is equal to, so what I would do is I would do 12.4 divided by, and I just do this to be careful. I will open a bracket, I will then push tan, I will then do 48, close the bracket, and my answer I get is 11.165. I'm going to round 2 decimal places, so 11.17. When you're approximating, make sure you put that little dot on top of your equal signs. So although I don't do it all the time in the notes, I do make sure I do illustrate, or I do put it in the instructions for you to do it during tests, just to show that approximation is happening with decimal places. So 11.17. Another way you could have done this was to simply have done tan 48, you get an answer, and then what you do is you do 12.4 divided by your answer function on your calculator, and you get 11.17. So try this out. Make sure you're trying these until you get the same answers as me, so that you know you're using the calculator properly. That's one of the most important things about this unit, is using that calculator properly. So now that we know all these techniques, we'll be able to solve for a triangle. When I say solve a triangle, what that means is basically find the missing parts. So find the side B, angle B, all the missing parts of a triangle using your knowledge of trig ratios, of angles, so on and so forth. And so we'll do that in the next video to come.